So last time we left off talking about the quarter, penny, and all the coins and their percentages. So we were looking at mass. So I'm going to redo one of these and then I'm going to let you work out the problems on your own. So let's talk about copper plated zinc. So you have 2.5 grams total, and that's the weight right here. And 2.5% of that is copper. Now, what does that mean? That means that 2.5% of 2.5 grams equals copper. And how do we do a percentage of a mass? So you just take the 2.5 grams, you multiply by percentage, which is 2.5 over 100 in fraction form. And when you do the math on that, you're going to get 0.065. And it says the balance is zinc. It's just trying to tell you that the rest of the 100% minus the 2.5% is zinc. So all you do is take the 100% minus 2.5, which is 97.5%. And you are going to take that 97.5% and take the 2.5 grams again. So we are going to do the same thing we did. Over 100. So basically it's really 2.5 minus the 0.0625, which comes out to 2.4375 grams are zinc. So that much is zinc and this much is copper. Okay, so if we try to do that with any of the other ones, let's say we'll do that with the dollar coin, which is right here. So total mass is 8.1 grams. And so you're going to take 88.5% of that. How many grams is copper? How many grams is zinc? How many grams is manganese? And then how many grams is nickel? So you're going to solve that problem on your own. And once you solve that, then we'll talk about the other thing. So that's the problem you're going to solve on your own, and you can do that on your own time. So let's go on to how this relates to the compounds that we have seen and some of the compounds that we have formed. So let's think about something like when we look at the periodic table, let's think about carbon. Remember when we looked at the periodic table, there was a number on top. We called this the atomic number. And then there was a number on the bottom. And remember, we called this the mass number. And we said that the mass number is the total number of protons and electrons, but also the mass number is actual mass in grams per a unit called mole. Mole is just a unit of an element. So let's say we have 12 grams of carbon, sorry. That's going to equal 1 mole of carbon. Okay, so now if the question asks you something like, how many moles of carbon are there in 5 grams? Right, so how would you solve a problem like this where you would try to determine how many moles are in a certain amount of mass? So all you have to do is say, okay, I know I have 5 grams, that's my given. And we know this right here from the periodic table. We know that for every 1 mole, we have 12 grams. Okay? And all you do there is really just divide the 5 by 12. Okay? And that's going to give you moles of carbon. Oh, I don't know why you erased there. Grams. moles of carbon. Okay, so we need to understand grams and moles. We're not going to do a whole bunch of those, but we're going to use that concept to do the mass percentages of a compound. Okay, so now you know that carbon is 12 grams. So let's say that I have carbon monoxide. Okay, and carbon monoxide, so this is carbon monoxide, that's that poisonous gas. So it's made up of carbon, right? And it's made up of oxygen. So you know that because you know from the periodic table, C is carbon, O is oxygen. There's 1 carbon to 1 oxygen ratio. Okay, now the question is going to be mass percentage of each one. So in other words, how many grams of carbon is there in the carbon monoxide, but in percentages, and I'll show you how we do that, and how many grams of oxygen in the total thing in percent form. So basically, just like we did with the coins, it's going to be a total and a part to total percentage. Okay, so we're going to do reverse of what we did with the coins. So mass percent of carbon, what that means is you go to the periodic table, you find carbon. Okay, you find carbon, we already know it's 12.01. And we just said that's the mass. Okay, so now this is grams per mole. We're not going to worry about the mole part, we're just going to right now worry about the gram part. When we go to the periodic table, we find oxygen, and it says 15.998. Okay, something like that. So we can just use 16. So we're going to round this to 16 grams. So if I want to know the mass of carbon monoxide, I know that I'm just going to round these. 12 plus 16. I know that the entire mass of carbon monoxide is 28. That means that 1 mole of CO is equal to 28 grams of CO. Okay, now the question is this. If I have CO, what percent is carbon? What percent is oxygen? Those percentages are only by mass. We just said CO is 28 grams total per mole. So then we know carbon is 12 grams. How many percentage is that out of 28? So part by whole, right? And then the rest would be oxygen, right? So all you're going to do is take the 12 divided by 28. So 12 divided by 28 is 0.42 or 43 times 100. So we're just going to say this is 42.85. So I'm going to round to make it easier. It's 43%. Now, if this is 43%, what do you think the rest is? Well, the rest is oxygen, and the rest is out of 100. We can, of course, do the math, but we expect to get a 57 here, right? Because 57 plus 43 is 100. All right, and that's what we get, 57%. Okay, so that's mass percentage. It's called mass composition, percent composition by mass. So I'm going to give you 4 problems that you're going to solve on your own. And then at 10 o'clock, you're going to log into Zoom and we're going to go over it together. So you're going to find the mass percentage of carbon dioxide, the mass percentage of sodium chloride. So you're going to find the mass percent of carbon, mass percent of oxygen here, mass percent of sodium, mass percent of chlorine here, and then of water. So that means mass percent of hydrogen, mass percent of oxygen. So then you are going to log in at 10 a.m. and we're going to go over. Okay, so I'll see you then.